So we'll continue from where we left off. We were talking about oxides and what they do when you add them to water, especially for mainly for period three. And I told you that oxides are going to react in two different ways. And I was going through your book, and the new one, the latest edition, has a small paragraph on this idea. So I'll just quickly touch upon that. That number one, when you have metal oxides, they have oxide ion in them. This oxide ion can accept H positive from water. And remember that water acts as H positive and hydroxide ion. So what it does is that this accepts in H positive ion, so makes OH negative. And water obviously has broken down to make H positive and OH negative. So this H positive goes and reacts. So this makes OH negative, and this OH negative is already there. So you get two OH negative. The non-metal oxides don't do that. What they do is that, for example, I'll come to them in a bit. Let's suppose I have H2SO4. Okay. Now H2SO4, if I add it to water, what happens? Water has lone pair. So this oxygen has two lone pairs. Okay. So water can take H from H2SO4. It takes the H positive from there, makes hydronium ion. This hydronium ion is basically this thing breaking down, giving us H positive and HSO4 minus. So H2SO4, remember, it is diprotic. Diprotic means it has two H positives in it. So it gives the first one away. Water accepts that. And water accepts that, makes dative bond with it, and gives us hydronium ion. Now, HSO4 minus just goes on the sides. And because of this hydronium ion, we know that they are basically acting as an acid. They have given this to water. So what this is the acid, this is the base. And over here in the metal, this is the acid and this is the base. Okay. That's why we say that metal oxides are basic and non-metal oxides are acidic. Okay. They're acidic because they're giving H positive, just like it's H2SO4 would. So for example, what happens if I put maybe silicon, not silicon, phosphorus oxide in water. So phosphorus oxide, P4O10, I put that in water. What it's going to do is going to basically form phosphate ion. It's going to take that O negative and it's going to form phosphate ion. And if you take oxygen from water, what is left? The H positive ion is left, right? So it forms phosphate ion and H positive, lots of them. And because of this reason, we say that this is acidic. There is H positive that it is given away. This is phosphoric acid that you're going to get. Similarly, if I add sulfur dioxide to water, this is nothing new for you. This is going to form it's going to form sulfite ion with H positive, two of them, three of them here. And similarly, sulfate, when it adds to water, it forms not sulfate, sorry, sulfur trioxide. When that reacts with water, it forms sulfate and H positive ion. So technically what's happening is that these non-metal oxides are releasing H positive of water, and that's why they are acidic. They are causing an increase in concentration of H positive. Could you say that again? I didn't quite catch that.
In the first equation, why do we have three H positive ions?
Oh, it's not balanced, but basically what happens is that you get phosphoric acid, and phosphoric acid has H3PO4 formula. Okay, I can balance this if you want. So this would form H3PO4, which will be, if I balance it, 4 phosphorus. So that gives me 12. So yeah, 6. So that is the equation. That's why we have 3H positive from one molecule. And of course, you can further balance this, 12H positive and so on. So that's what these things do. Their non-metal oxides are acidic and metal oxides are basic. And the reason that happens is, again, I've explained it to you. Another thing, if they're acidic, will they react with alkalis? Yeah. So oxides of aluminum, oxides of silicon, there it is super. So silicon dioxide or aluminum dioxide, they're both insoluble in water. But we also know that they're acidic because if I react them with sodium hydroxide, they will react. So if I react them with sodium hydroxide, what happens is, especially if something doesn't react right away, we usually heat sodium hydroxide. So they will form salt. So that is again something that aluminum oxide will do because it's an acid, it's an amphoteric salt. With sodium hydroxide, it's going to form salt. So both of these, even if they're insoluble in water and we can't really determine whether they're going to be acidic or basic, they will react with alkalis, and that shows that they are acidic. Okay, so both of them make salts. So silicon dioxide will make sodium silicate, and aluminium oxide will make sodium aluminum hydrate. अब वो भी कैसे बनता है, we will talk about it when we go over the organic mechanisms. Once we understand organic mechanisms, then we can revisit this, और उससे हमारे लिए आसानी हो जाएगी इस रिएक्शन को समझने में. So this with hot concentrated sulfuric acid, sodium hydroxide. Why are we using hot and concentrated? Because silicon dioxide would react really, really slow otherwise. So we are using this. So it will create sodium silicate. This is showing that sodium hydroxide, which is a base, is reacting with the acid to make salt and water. Similarly, this thing with sodium hydroxide will form sodium aluminum hydrate and water. Some water is used up, so usually इस equation में उसको लिखते नहीं. So there you go. You're getting another salt. So this salt formation, this water formation, shows that these are acidic. Aluminum oxide will, however, react with acids as well to form salt. वो उसके साथ भी करता है. मतलब aluminum is special in the case that if I reacted with, let's say, sulfuric acid, then it will react and will create aluminum sulfate and water, of course. So that's again neutralization. So this shows that this thing is amphoteric, but silicon dioxide is acid. So the trend is from the left side, there are bases, and as you go towards the right, they start becoming acidic, and that's what they're going to do. I take K2O, which is potassium oxide, and add it to water. Complete this equation. So in this one, again, you have to understand what the structure of oxide here is. Oxide is ion with lone pairs. So it will take H positive from water and make hydroxide. Okay. So this K2O is going to convert to KOH, and there is another OH coming from water. So you're getting plenty of OH minus. That's what you're getting. So what happens, again, let me reiterate. Water, before it reacts, converts to H positive and OH negative. This H positive is reacted with oxide and it makes hydroxide. So you have two hydroxide now. Both of these hydroxides react with potassium, make 2KOH. Okay, so that's it. That's the concentration. Okay, what if I take K2O and I react it with nitric acid? What will happen then? Go on, try to complete it. This is aqueous and this is dilute, not concentrate. So I take K2O, I react it. What will happen? This should be easy.
Where does it make potassium nitrate and water?
Yes, it does. And this is a manifestation of its basic nature, that it's doing neutralization. So that's it. Those are the oxides of period 3. Now we talk about chlorides. And chloride, if you understand chloride, you understand other ones like halides and all that. So chlorides of period 3. So here's the thing: sodium through chlorine, we get sodium chloride, magnesium chloride, aluminium chloride goes in this form. There is AlCl3, which converts to Al2Cl6. Then we have SiCl4, we have PCl5. PCl3 is also made, but PCl5 is there as well. Then SCl2 is made, and chlorine doesn't react with chlorine. So that's it. They don't really form chloride. In all of these, you can see that chlorine is -1. And if I focus on the ones that are below, sodium is +1, +2, +3, +4, +5, +6. So what this is technically showing me is that chlorine is the most electronegative element in all of them. Okay, sure, there are others as well, like S2Cl2 होता है, exist करता है, या PCl3 exist करता है, ठीक है? But the oxidation numbers are still higher then the oxidation number of chlorine है इसमें ये +3 होता है और इसमें ये +1 होता है and इसमें भी ये +3 होता है. So the oxidation numbers are basically showing that with all others, chlorine is the one that is most electronegative, and that's fine. That is fine because chlorine does have high electronegativity compared with all of them. In fact, it is the fourth element in the order of electronegativity. So why shouldn't it get negative charge first? Okay. Now the next thing is the structure. This is ionic sodium chloride, giant ionic. It is forming a lattice. Magnesium chloride, ionic. Al2Cl6. Interestingly, this is covalent ionic. So AlCl3 is covalent because aluminum is sharing 3 electrons with it. And we have talked about it when we studied dative bond, that how does this work. Then we have, again, simple molecular. Okay, this is covalent and they're both molecules, and so on for these two. All of them are molecule. These two are giant ionic lattices, but all these four, in fact, the rest of them as well, they are molecular structures, simple molecular structures. Okay, that's the structure. And the examiner does ask you sometimes that describe the structure of this chloride and all that. Now, what happens if you put them in water? Let's see. Sodium chloride, we have all experienced it. You put it in water, what happens? There is a big explosion, right? Yahi hota na? Actually, no, nothing really happens. This is a white solid, it just dissolves. And the solution is colorless. And that is the case with sodium chloride, that is the case with magnesium chloride. They dissolve, white solid, and it converts plus water, and you have a colorless solution. That's what you get. Okay, so pretty tame. The pH of the solution, this one is 7, absolutely neutral, but this one is slightly acidic when you with magnesium chloride because of some reasons, like chlorine has lone pair, तो वो donate करती है and all that. So H positive निकल आता है उसमें से. Okay, what happens on the other ones? So sodium chloride dissolves Na plus Cl minus बन जाता है. Okay, sure. Al2Cl6, we might think that this is lattice, but when you actually see it, it melts at very low temperature. It boils at low temperature. It does not conduct when you dissolve it in water. And that those are good hints for us to know that this is not technically ionic. What AlCl3 is that aluminium is sharing 3 electrons with chlorine, but the moment it gets a chance, it can convert this to, so instead of having this, 2 of these can combine together and they will form this thing. Sorry, don't mind the noise behind me. This is a dimer. What's happening is that chlorine is sharing lone pair with aluminum. Okay, and that is how you're getting this dimer structure. This is a dimer. The 2 molecules have joined together. Remember O-levels from monomer and polymers? So the monomer was 1 molecule and then the next one. And dimer is the form that it exists in when you have water. You do have AlCl3 when you get water. Like if I add water to it, AlCl3 will exist because it can form dative bond with water. Okay? So that is the structure of AlCl3. What happens when you add water? This dimer breaks down, and water actually ionizes them. And because of that reason, what happens is that aluminum is able to make a complex. A complex is again a new kind of particle that we haven't seen before in O-levels. And the reasons for that is because when some metal atoms are able to get access to their d orbitals, they can make dative bonds with many, many different species, different molecules. And because of that, they make a new thing, which is called a complex. I'll give you an example. So aluminum is 3 plus, right? We have seen that as 3 plus in water, but it's not actually 3 plus. What happens is that aluminum ion in water has lots of free orbitals, and water has lone pairs on it. So 6 water molecules are able to come towards aluminum and form dative bond with it. 6 water molecules. So there's 1, 2, 3, 4. Let me make 3D formula. So what happens is that there's 2 behind it. So the dotted line means it's inside the screen, and this wedge means it's outside the screen. So there's a water molecule here. I'll just write AQ, okay? So you know that water has oxygen with, although AQ is not the term, the preferred method in exam, so don't write AQ in the exam. And this is below it, this is above it. So there's 6 water molecules that are able to attach to this aluminum and form this thing. This is called aluminum with 6 water, and I'll write that as aluminum and 6 water with a +3 charge. And this is called aluminum hexahydrate. Now, here's what happens if I put it in water. In water, what it's going to do is that one of the H positive is going to go away. So if I put it in water, one of the H positive is going to go away and give me just this. It's going to form aluminum with 5 waters, 1 hydroxide, and H positive. Now, what's the charge on hydroxide? -1. What's the charge on aluminum? +3. So what's the overall charge? +2. So अब ये आपको अभी बहुत कंफ्यूजिंग लगेगा, लेकिन A2 में जब आप ट्रांजिशन मेटल्स पढ़ोगे ना, उसके बाद आपको ये देख के लगेगा कि हाँ ये तो बच्चों वाली बात है, ऐसे ही होता है और तो कुछ नहीं होता, right? So for now, if this formula and this structure seems daunting, that's perfectly fine. That's perfectly normal. And in AS exams, they don't ask you to write these formulas. But because I want you to be prepared for A2 Satsati, so that's why I'm sharing this with you. So हम इसको वापस revisit कर सकते हैं next year. But for now, just remember that aluminum, because it has this many free orbitals available, it is able to form complex, and that complex with extra water can break down and give us H positive ions. Okay, so that is how we know that aluminum trichloride is acidic. That's the main thing I wanted to share with you, that aluminum trichloride, when you put it in water, the diamond breaks down. That dimer, when it breaking down, it forms this aluminum hexahydrate complex, and that complex further ionizes to give us H positive ion, which is why this is. Similarly, the next ones, they are purely acidic. That is pretty straightforward. SiCl4, if I put it in water, it's going to form SiO2 and HCl. What's happening is that basically it's creating H positive ions from water, and that H positive ion is reacting with chloride to make HCl. The remaining things, they're just pieces collecting together, so SiO2 ban jata hai usse. This dissolves in water when it reacts, but it creates a solid that starts to settle at the bottom, and HCl goes away, fuming away. Okay, and this is a very fast reaction. And silicon tetrachloride is very reactive compared to silicon dioxide. Okay, now what happens is that this is right now an off-white precipitate. It's a solid that settles at the bottom. But of course, sand has a lot of it, which is why we usually see कि white तो नहीं होता, but it's actually off-white, and many gemstones actually have this. PCl5 and other chlorides of chlorine, they will dissolve in water for the same thing. So the chlorine is going to go make HCl, which is acid, as you know, and the remaining part is going to react with oxygen. And what happens when you react phosphorus with oxygen? You get phosphoric acid. In presence of water's hydroxide ion, this phosphorus reacts with it. Think of it like this. Every chloride is going away and giving us an OH minus in some sort. And those chlorides form HCl, and then the remaining thing forms phosphoric acid. Okay, HCl is gas. The reaction is exothermic, so this is a gas, it goes away, and that phosphoric acid remains in water. This is liquid, sorry, and this is solid, PCl5 and dissolves. They're both soluble in water. PCl5 is soluble, HCl is soluble, H3PO4 is soluble. Okay, this is a diagram of this reaction. So this is basically PCl5, the solid white solid over here. This is PCl5. When you add it to water, There's fumes of HCl coming out. So it can be pretty dangerous doing this in the lab because you're getting HCl fumes. Okay. So here's the thing. Just to summarize it, basic, basic, sorry, sodium chloride, neutral. When it adds to water, just dissolves, no reaction. Magnesium chloride dissolves in water, slight reaction, makes H positive. That is a hint that this is becoming acidic. Aluminium trichloride exists in water, breaks down, forms complex, which further breaks down, gives H positive ion, acidic. SaCl4 makes HCl strongly acidic. PCl5 strongly acidic. SCl2 strongly acidic. And SaCl4 is going to create SiO2. PCl5 is going to create phosphoric acid. And SCl2 is going to create sulfur dioxide. Okay, so those are the chlorides of period 3 and how they react with water. Again, the reason is coming from the dative bond that is able to form from phosphorus, and the dative bond is the reason why they react the way they do. So हमारे पास ये हो गया. Now, how do they form them? They all just react with chlorine. So आप chlorine पकड़ो high temperature पे या वैसे भी इनके साथ उसका reaction directly हो जाएगा. Silicon will react to create SaCl4, phosphorus will react to create PCl5. हाँ वो reaction हीट करने से जल्दी हो जाएगा, वैसे ये सारे रिएक्शन बड़े स्लोली कर. मैग्नीशियम, एल्यूमिनियम एंड सोडियम रिएक्ट फास्ट, द रेस्ट ऑफ देम डोंट. What is the color of sodium's flame? Does anybody remember?
Yellow.
Yellow, yeah, exactly. So here's the thing. Silicon, phosphorus, sulfur, all three react slowly with chlorine, but their chlorides react vigorously. When they form these chlorides, they react slowly, but these chlorides react very vigorously. Okay, that is something you have to remember, and that makes sense. एक चीज बनना ही नहीं चाहती तो वापस जाने लगेगी वो बड़ी तेजी से करेगी ना. So यहाँ पर टेक्निकल बात समझने वाली सिर्फ वो एल्यूमिनियम वाली है, that the dimer which normally exists when there is no water breaks down, makes the monomer, and then ionizes it, and that ionized aluminum forms a hexahydrate complex which breaks down to give H positive ion, which shows that this is acidic. And that brings us to the end of this chapter, periodicity. And yeah, in the inorganic section of the syllabus, this is the more technical side of things. Now we're going to talk about group 2 and group 17 from tomorrow. So in fact, I would like to focus on past papers questions for this one.